All right, today we're looking at the idea of diagonals and then how that can help us to understand interior angles and exterior angles found within different types of polygons. So first of all, what is a diagonal? A diagonal, of course, is a line that starts at one vertex and goes to another vertex, but of course it doesn't touch an adjacent vertex such as here or here. And so in this quadrilateral, of course, there's really only one diagonal coming across like that, because from here to here, that would not be these, this, and this would be adjacent. So it doesn't fit the bill. So we come away with one diagonal. Now, with this point in mind, we want to be able to take a shape such as this, and we want to be able to draw the diagonals. It says from one vertex of regular hexagon A, B, C, D, E, F, how many diagonals can be drawn? So we're going to pick a point. I'm going to start with B. And from here, I want to start drawing my diagonals. And so I'm going to throw some nice colorful lines here. So going from B, I can't go to A because that's adjacent, so I can go to F then. All right, so there's one diagonal. And then I can go from B, and I can't go to C because that would be adjacent, but I can go down to D. That is not adjacent. And then I have one spot left over, and so I can go like that. And so in the end, I see that there are 3 diagonals in this regular hexagon. From here, we want to be able to understand how we can use that concept to learn a little bit more about our hexagon. From here, I already said that, we have this term up here, interior angles. And the green circles here represent the interior angles. All of these circles would qualify as an interior angle. It's an angle inside the shape. Since it's an interior angle, how are you going to solve for each of those measures? And the diagonals become the key. Because as we look at our diagonals, what we can notice is that what we've really done is we formed triangles. There's one triangle. Here's a triangle in this space, right? We would say there's a triangle here, and then of course there's a triangle right here. And because of that, we're really given some really important information, because we know that all triangles add up to 180 degrees. So that means this angle plus this angle plus this angle equals 180. Just like this angle, and this angle equals 180. And you can get the drift of where I'm going with this. That equals 180. And of course, our last triangle equals 180. So because of that, I can take 180, multiply by 4, because there are 4 triangles inside of that, and get what A plus B plus C plus D plus E plus F equals. So do some quick multiplication. I get an answer of 720. Now 720 is all of the angles added together. So A plus B plus C plus D plus E plus F, because I've included everything by putting all of these triangles together. So to figure out the measure of one of them, I'm going to take this and divide by the number of angles. In this case, I have 6. So 720 divided by 6 is going to give an answer of 120 degrees. And because it's a regular hexagon, I would say that A and B and C and D and E and F all measure the same of 120 degrees. All right, review that picture. Make sure you understand what's going on as we jump to the next concept. Now, from here we can move on and talk about, well, what about the outside? Exterior angles. Exterior angles is something that we've looked at this relationship before, and a lot of it has to deal with turns. But for this, we can talk about this relationship. We just determined that each of these angles equals 120 degrees, which means that as we see this dotted line being extended, we want to know what the measure of that angle is right there. So how are we going to solve this? Someone just shouted supplementary angles at me. I hope no one's looking at you funny because you're shouting at a computer, but yeah, exactly. They are supplementary angles. Because this line is going this way and it continues on going that way, that would be a straight line. We know a straight line has a measure of 180 degrees. And if this part of the line is 120, that means we would subtract 120, the interior angle, from 180 to get our exterior angle. And in the end, we're going to come away with the fact that this angle right here is equal to 60 degrees. And because that's equal to 60, that means this is equal to 60, because all of the angles were the same on the inside. We come away with this idea. So one of them equals 60. And here's a really cool thing that we're going to also talk about. The fact is that if I were to take 60 and multiply by 6, we get an answer of 360 degrees. And if we think about that, what we've just formed by going around this is we formed a circle. By going completely around the shape, we have formed a circle. And of course, all circles have 360 degrees of change, turn, 360 degrees for circles. That's the key idea. Which means if I go around any shape, if it's a triangle and I go around it, all of my exterior angles will equal 360. So if I go around a triangle, there are 3 exterior angles. I went in a circle, 360 divided by 3, 120 degrees is my exterior angles for a triangle. Wow, neat little trick. All right, here is your sample problem then. It says, what are the sum of the interior angles and what is the measure of the sum of the exterior angles? Go ahead and work with these problems as you deal with diagonals, interior, and exterior angles.